So if I get this correctly, it's a company at a valuation of $2.75 billion, and they are accelerating innovation through unifying data analysis. And so Reynold is also is previously a PhD in computer science, graduated from UC Berkeley. So without further ado, let's welcome Reynold to the stage.
All right, thank you. It's short. Make sure you sign in. Usually when I give talks, I know exactly what I'm getting myself into. I know very well the audience, at least the background of the audience. I don't quite know who's in the room. And we have sort of technical students have sort of more business oriented. So it's a somewhat difficult talk to give. So rather than just me talking, feel free to ask questions. If there's anything you feel I'm going too slow, too fast, maybe half of the room feels too slow, half of the room feels too fast. So let me know, all right? And I want to talk to you a little bit about sort of how Databricks has started and some of the trends we see in the market. So when it comes to AI and big data and cloud. And the other day I was thinking about how to explain to Databricks to other people. And then I realized if I were to put as many buzzwords into it, I could just do it like that. And it's actually a very accurate description. We're sort of a company, a cloud-native company that's offering a big data AI solution to enterprises. Right. A little bit about myself, founder, chief architect. I designed most of the, I would say, the foundations for modern-day Spark, which I'll explain in a bit. Number one contributors to it. For those, are there any computer science students here? People that write code? Some of you? All right. What I'm really proud of is I deleted more code than I added to a project, which is actually somewhat difficult to do. Previously, I was doing my PhD in databases, more specifically, so a sub-area of computer science at Decode. In this talk, I'm going to talk about Spark and Databricks, and we're going to talk about sort of why I think AI, big data, and clouds are really intertwined trends. They're not three separate buzzwords. They're sort of highly integral with each other. Right. So to tell you a little bit about the story of, I'm going to tell you a little bit about the story of Apache Spark, which is an open source project that Databricks, the company, was founded based on. Right. And the story of Spark started with this guy called Lester. And this has to go back almost a decade ago, 2009, 2008, 2009, more than a decade ago. And Lester was a PhD student here at UC Berkeley doing machine learning research. Right? At the time, how many of you heard of this Netflix prize subset? All right. So about a decade ago, Netflix decided they're going to create a competition. And the competition is very simple. They anonymize all the user movie rating data sets on Netflix. So every time you go rate a movie on Netflix, they sort of save a copy of that. And they anonymize all of that so you can't correlate with the actual individuals with the ratings. And then they publish a data set. And they created a competition out of it. Whoever they can come up with the best movie recommendation algorithm for that data set will win $1 million. So Lester was a PhD student who was making about $2,000 a month out of his PhD stipend. $1 million is a lot of money. So Lester decided to compete. He wants to win $1 million. And then he sort of started downloading that data set. He realized for the first time there was a data set that would not fit on his laptop. Right. Before he was working with academic toy data sets in academia, and all the data set was pretty small. Netflix data set was actually a real-world large data set, and it didn't fit. So he needed to sort of scale out and leverage sort of a cluster of computers to crunch the sort of build models. And then he looked around, he realized the tools back then were really crappy. There's no good tools that allows him to iterate very quickly. And one of the things with building machine learning models is it is not about whether you can build the best model at any given time. It's about how fast you can iterate to improve. So you build some baseline and start improving on it. You want to do it very, very quickly. You'll be doing sort of thousands of experiments every day, even millions. Right? So we talked to this guy, Matej Zaharia, who was at the time also a PhD student at Berkeley. And Matej was focused on computer systems. If you don't know what that means, and Lester kind of told Matej, hey, I think all the tools out there are pretty crappy. I think if you give me just few primitives and you build a new system for me, it doesn't have to be production ready, but it should really help me in improving my iterative speed. And as a result, maybe we can win the competition and can split the $1 million with you. Right? So this like, sounds good. We started and wrote sort of the first version of what we call Spark. Was the open source framework. They later actually open sourced it about a year later. And it became sort of a very interesting system in that it tries to combine functionalities that needed for doing a lot of data manipulation at scale, as well as building machine learning models. So before Spark, there's kind of disparate systems. There's sort of data systems that's good for processing data, and there's machine learning sort of systems that's good for running, so doing model training and building models. There's nothing that bridges the two. Spark became the first one. The first version was super simple, 600 lines of code, written actually over the course of about 2 or 3 days. Right. And then just fast forward a few years, Spark exploded. Actually, before I do that, I'm going to weave in a little bit of Databricks here. So, for those of you that's waiting to hear what happened to that $1 million, okay. Not right now. A little bit of suspense. So, when they created this system, they realized, hey, there's actually some value to the world. It's not just something you could use to win a competition. So they open sourced it. As a matter of fact, slowly over time, a lot more contributors started contributing to this open source project, and companies started to pick it up. But it wasn't sort of an overnight success. A lot of us joined the project later. Like for example, I myself joined to work on Spark the project. And then in order to actually get people to use it, you can't just put something on the website for something sort of data center scale and expect people to use it. We started just going down Silicon Valley companies and knock on their doors and ask them, hey, there's this free software we built. Why don't you try it? Most told us, hey, you're insane. We're not going to put something academics wrote in production. There's like a couple that tried it initially, very small companies, and then the buzz started to get down and more started trying it. And through that, we had a sort of a very interesting opportunity to look into how data pipelines and machine learning were done in a lot of the different Silicon Valley companies. Right? And then we realized sort of one thing. Everybody was building the same thing. Everybody had data they could gather from their web applications, from their sensors, from some logs they have, and they aggregate all of that, and they clean them, they transform them, they dump it somewhere, so it's ready for analytics. And that means you could build dashboards out of it so you can see how your business is doing, or you could be building more sophisticated machine learning algorithms on top to predict maybe how your business is going to go or how your business should go in the future. Right? So everybody was doing the same thing. Everybody was kind of leveraging technologies that were not quite designed to work well together. It's very clunky. Systems usually very fragile, right? And we see sort of teams of people in different companies doing exactly the same thing. We've asked ourselves, why don't we go solve this problem once and for all, just create a new company, focus on this, right? So 6 of us, all sort of Berkeley actually a combination of students and professors, started this company, Databricks. One of the founder actually, after he graduated, he joined Stanford to become a professor. We don't hold that again. Anyway, and Spark, so we also spent a lot of time working on the open source projects. We believe in a rapidly evolving field, we want to create a standard, and the easiest way to create a standard for a small little company is through open source. If you are sort of a incumbent with maybe $1 trillion valuation, you can do whatever you want. But as a very little small company, in order to create a standard that the entire world adopts, it has to be open source. Right? So we spent a lot of time building out sort of the open source ecosystem, which is basically Spark, to the point that it gained a lot of momentum. IBM called it the most important open source project in a decade. You might ask, who cares about IBM? Now, this one's more interesting. Derek Harris from Fortune magazine wrote, I think this happened in September 2015, so just probably a few months after the IBM one. Spark's the Taylor Swift of big data software. So I started showing this to my wife. For the first time, I could explain to her what I've been doing. And then she asked me, so what does that mean? Like Spark's a Taylor Swift of big data software. I'm like, I don't know. Let me email Derek. So I actually emailed Derek. And Derek got back to me. He said, Spark came from nowhere, rose to prominence, and then so it became ubiquitous. Very similar to the Taylor Swift trajectory back in, I guess, 2015 and 2014. Anyway, we started developing sort of open source community. There's more than 500,000 sort of members, like technical, we're talking about engineers here, around the world that started Spark meetup groups. You've just organized meetups themselves, as you can see, sort of the ecosystem. Right. We made it to Stack Overflow's developer, just for those of you not in tech, Stack Overflow is probably the largest community of engineers in which engineers go ask questions and then they get answers. People just do it for free. It's a very good and interesting community. But they do this annual survey among all sort of their members. And in 2016, Spark was rated the top 10 in tech. So if you want to make more money, you should learn Spark. At least there's a correlation. And it was also the most loved, become one of the most loved technologies here in the 2017 survey. I think it was also the most dreaded technology too, one of them, because it's actually very difficult, a lot of these tools. As good as Spark is, it's still difficult to use. Okay, so what happened to that $1 million? All right, so this is a leaderboard, the Netflix prize. And Lester was part of the ensemble team. All right, but look at the best score. They were tied. All right, they submitted 20 minutes late. This is literally only 20 minutes. So they lost $1 million to a different team. All right, so if Spark were invented 20 minutes earlier, Lester would have been $1 million richer. Anyway, Lester's fine. He was very accomplished academically, research-wise, and he became a professor at Stanford later, also Stanford. And then I think recently he actually he might have. He's more of a machine learning. He's a theoretical machine learning researcher. This is just kind of a side hobby he did. Right? It's not bad, right? So this is how good he is. So the side thing, he became sort of the number 2 in the entire high-stake competition. He might have actually quit his professor job and went to Boston recently for I think his family reasons. But the Lester story didn't end there. It kind of led to sort of the creation of Databricks, the company. Right? And here's a picture of the other team happily taking $1 million.
So did the other team create something similar to Spark?
No, I think they just use like a bunch of other ad hoc stuff. Yeah. As important as Spark is one piece of the puzzle here. It's not like everything. Right? And we started Databricks in 2013. All 6 founders were affiliated with Berkeley, either students or professors or postdocs back then. And so today we are one of the fastest growing enterprise startup in Silicon Valley, probably the world, in terms of revenue. And what we do is offer a unified analytics platform in the cloud for data science, data engineering, and AI. Right? We have over 2,000 customers across a lot of different sectors. We're more of a platform company. And that means we don't sort of solve a specific application from a specific verticals. What we do is provide a platform for other organizations to leverage and to be building applications on top of us. Just to give you maybe 3 examples to give you a sense of what our customers do. So the first example is Regeneron. It's one of the leading pharmaceutical companies in the United States. What Regeneron does on sort of our platform is they use our platform to correlate the electronic medical records of 50,000 patients with their DNA. And the reason they do this is they actually built one of the largest genome databases among pharmaceutical companies. And for pharmas, the cost of developing a new drug is insanely high. We're talking about $1 to $5 billion per drug. And the reason it's very high is it's a very lengthy process. You have to do a lot of different experiments. You have to try different things. And once you have something that you feel might work, you start doing clinical trials. And clinical trials, the process itself is very expensive. Right? For those of you that in life science, you understand this. And so the latest trend in drug development is you leverage data to prune the space as much as possible. So rather than trying a lot of different things and later realizing it doesn't work, you try to prune it very early. And you based on data, you say, this most likely won't work, I'm not going to go down this path. Right? And the ones that do well will substantially reduce the amount of money they spend in developing a drug. For example, I think Regeneron spends maybe like somewhere between 15 to 20% of the industry average in terms of per drug cost. Right? And a lot of these are built on data. The specific one they're working on, I think on Power Databricks platforms for chronic liver disease. Second example is Salesforce, another enterprise company. What they do is they sort of build, just expand NLP, natural language processing on top of Databricks. So you can make recommendations to the salespeople and their customers on who to contact, what to do next. Right. The other one is Riot Games. Riot Games make League of Legends, one of the most popular games. And for all this gaming company, once you have a game that's out there, maintaining an in-game experience is extremely critical. And one of the very simple way of destroying that experience is have a lot of this abusive behavior. And in games, mostly you don't talk, you just type. People start making up, creating new words for abuse. And it's sort of evolving target. And what they do is they basically do machine learning models to understand and predict whether a specific sentence or a specific word might be abusive behavior. And if it does, they ban that person very quickly so it doesn't actually pollute the entire game. And going back to sort of the power area, here's some examples, but one other example I want to bring up is kind of more on the creepier side, is Netflix wasn't the only one that's trying to sort of improve their movie recommendation. Right? At the time, I think it was about a decade ago, we saw, it was still confidential back then, I think it's public now, there was a project at Facebook that by mining the logs of people clicking photos, they can predict with high accuracy whether a couple is going to break up. I don't think that was ever rolled out. It kind of tells you the power of all of these projects. All right. So now, getting to the second half of my talk. Any questions about the first? So mostly just history and what's possible.
Yeah. So like is the reason why you the group of you started trying to sell this software created to Silicon Valley companies that you guys lost the competition, or?
Oh, is that the reason? No.
How did you came to think? Okay, maybe we should start selling this thing to the companies and then see if we can gain some traction and make a business out of it.
Yeah, in the beginning there was no sort of ambition to do a business really in the beginning. It was just mostly, I think a lot of engineers probably understand you just want to build something that people use. There's no sort of aspiration to we're going to build like $1 billion company out of it. It was mostly just, I really want to create something and see it used. And that's why we're talking to the Silicon Valley companies. For many of them, we weren't even charging them money. Like actually, it's open source software, so they could use it for free. Yeah. For most of them, we didn't even charge them consulting fee. Yeah. One of my favorite stories was Matei, who was a very highly accomplished person. He spent like a whole day working with sort of a startup in San Francisco to help them set up Spark and get it to run on their workloads. And then at the end of it, the company sent him a $50 Amazon gift card after a whole day. But that sort of shows you we weren't there for the money.
Right. Just for evangelizing.
I just wanted to read it. And this one there.
Oh, I was just curious about like the breakup of like couples. Like, what do you mean by like photo click stream? Like, how does that work?
When you, I don't know if you guys use Facebook these days, but if you use Instagram, when on Facebook, when you click a photo, it shows up your newsfeed and you might click into it, you might not. Every time you click something, it gets logged. So Facebook knows you're clicking on some photo. Right? And it knows whose photo it is. It knows how often you view them. And it's actually somewhat trivial to build a model based on that data to predict whether, for example, if you're currently in a relationship, it's somewhat easy to build a model to predict you might break up with your girlfriend, say 3 months later. That's sort of the power of, I mean, it's mostly using correlation. Right? It's probably a high correlation here between, say, a married man clicking a lot of pictures of some other specific female friend. And the person having an affair. All right. I mean, machine learning is mostly just correlations. It's not that hard. It's like fancier Excel trend line. Okay. So now, why am I talking about this? I don't really know the audience, so I'm going to try my best to see if I can explain it clearly. Right? So one of the things with all of this is you need, the way you do machine learning, you build models, is you come up with sort of a design and you train a lot of data. Right? And then you draw sort of correlational behavior out of it. And then you apply that to new data that you don't know sort of the value you're trying to predict. Right? So data management is actually a very important part of machine learning and AI. And the world runs on databases. You've probably heard of this term, even if you're not in computer science. And databases were invented, or more precisely relational databases, were invented basically in the 70s. And later there's a newer term called like data warehouses, which become basically the central data repository for all the data in a big company. Right? And data warehouses itself is a very large market. I think it's somewhere between $10 to $15 market for data warehouses. The kind of company we're associated with it, Oracle, IBM, Microsoft, Teradata, the market largely hasn't changed a lot since probably the late 90s. Right? The same players are still very active. And this is sort of the type of technology that powers a lot of the businesses out there. Like probably, for example, the UC Berkeley, the Cal Bears, a lot of the systems actually run on some databases and some data warehouses. Now, one of the problems with all of this is they were designed to be very rigid, meaning you have to get everybody to get together and agree on a data model. And data model sounds like a fancy word, but really just means what columns do you have, what are the types of the column, are they like a numeric value, are they a string value? You kind of need everybody to agree on the same thing before you can start putting data in. Right? And in a lot of large enterprises, we're talking about 3 or 4 years for that to happen. Because there's so many different data sets in a typical enterprise, and there's so many different teams and stakeholders, and there's politics involved. People do, you can structure data in this way, you can also structure it in a different way, and of course, can't get along and agree on one thing, right? So it becomes very difficult to build, and it's a very lengthy process to be building this. Now, this is okay if your data, so your applications don't change that much. Like for example, if you are, actually, let's say the course selection system at Berkeley, it's the same functionality for the last probably like 100 years, right? Courses might change, but it's the same functionality. You go online, you pick a class, and if it's full, you can't pick it. It's basically the same thing. So when applications don't change forever, it's actually okay to spend probably a few years agreeing on the data model. But if your application is changing every day, and you keep having new things to do, and every new thing you do might or might not fit the existing standard you agreed on, and you have to take another 3 or 4 years to come up with a new standard, it's just too slow. You can't iterate fast enough. Right? So they kind of, I think, led to the rise of, in a way, big data, which I think the word probably started becoming popular in the late 2000s. And big data is characterized by 3 V's. One is volume, the other one is velocity, the last one is variety. These are the 3 V's of big data. If you go search for it, I think an analyst from Gartner came up with it. So it's kind of the volume part is self-explanatory. Big data probably means you have a lot of data. Like rather than before maybe you're collecting, say, you just have the user information of some account. Now Facebook can collect, every time you click something, Facebook knows, right? So they start storing more data. But the other 2 is probably actually more important than just volume. Second is velocity. It just means the rate of data generation is also accelerating. It's not just about the static volume, but also the rate of generation. And the third is variety, which means before you might just have strictly tabular data. Now you're getting, for example, image data. You're getting the sensor data, time series data, and all of these are very new and different, and it's difficult to put in the relational data. So I think Google kind of pioneered a lot of the concepts in big data, software concepts. But then really, there are 2 other companies that probably sort of seeded the market. Cloudera and Hortonworks, both IPO probably 3 or 4 years ago. They actually just recently merged. They're not doing super well right now. But they were based on this technology called Hadoop. And Hadoop was initially, so the story of Hadoop is it's an open source technology similar to Spark. Means it's free, anybody can use it, anybody can contribute to it or change it. And it's initially built by the teams at Yahoo, and based on 2 papers some Google engineers wrote called Google GFS, Google File System, and Google MapReduce. And then they sort of came up with an open source variant of that. It's called Hadoop File System and Hadoop MapReduce. Right. And the concept of Hadoop is, hey, rather than you have to spend 5 years coming up with a data model before you can put data in, I'm just give you the ability to dump anything you want into this thing, and then call it the data lake. And worry about analysis later. Don't worry about how you structure it. Just dump whatever you have in whatever way it's generated, and then we'll analyze it later. So in a way, actually commoditized storage. It makes it extremely cheap now to store a lot of data because you don't have to buy expensive hardware. You don't have to buy expensive databases. You don't even have to spend, probably the worst part, come up with a schema, come up with a data model. But it actually, the one thing that's very interesting is if you actually interview most of the Hadoop users, they will tell you, hey, it makes it very easy to store, basically easy to dump, but I can't analyze them. Because the data quality is so bad and the whole thing is designed to be very slow, and I just couldn't make it to work. Right. And Spark, in many ways, addressed, I would say, the analyze layer problem. This is what made Spark popular. Is now people can actually use it to analyze the data they dump. Now, the other thing is cloud. Let's talk about ABC, right? AI, big data, cloud. The cloud computing. So cloud computing is. I highly encourage you to actually read this paper. It's an academic paper in computer science, but it's actually written in a way that anybody can read. My wife sort of graduated from Haas here at business school, and they had to read this paper as part of their Haas class. It's actually not super technical, right? This is, I think, by far the best explanation of what cloud computing means. If you don't have time to read, here's sort of a phrase summary of the entire paper. Cloud computing basically gives users the illusion of infinite computing resources. So rather than, for example, hey, here's a laptop, but here's a cluster of 5 machines, and that's all I have. You imagine it's infinite computing resource, right? You can get as many CPUs, as much memory as you want. And eliminates any upfront commitment. So you don't have to spend a lot of money to buy, for example, a machine. Right? There's no, in order to build a data center, for example, 1,000 machines, it costs hundreds of millions of dollars. In cloud, there's no upfront commitment. And instead, you have the ability to pay for use as needed. And what this means is anybody, literally anybody, could swipe a credit card, get, for example, 1,000 machines just for half an hour, and you get a lot of compute resources just for that half an hour. And that was just previously not possible before. Right. Now, why does this matter? So, with all the examples I talked to you about, Facebook, the creepy one, developing new drugs, the way they do it is, it's actually relatively simple. They take huge amount of data they can gather, and then they have some machine learning algorithm, typically mostly already implemented, and then they run the machine learning algorithms on a huge amount of data. So the keywords here are one, you need a lot of data. Second, you need a lot of compute to be able to actually run those models, to train them, right? So that's why cloud computing and basic big data is very key to this whole AI space. And actually, Google themselves document, let's get this one. To illustrate you with more sort of, this is probably the most technical diagram here. Google wrote a paper called The Hidden Technical Debt in Machine Learning Systems. It was published in NIPS 2015, and NIPS is the sort of the top machine learning conferences. And in this, they had done a study. They analyzed all the machine learning systems within Google, and then they grouped the different components of those machine learning systems into different pieces. And each box represents a component. Like, for example, configuration is a component, data collection is a component, verification, machine resource management, serving, and all that. And the size of the box indicates the amount of code that was written for those components. So sort of in a way semi-correlated with the amount of efforts you have to spend. Right? In the middle of it, there's this tiny little green box. It's called ML code, machine learning code. So the vast majority of the effort when you need to build a machine learning system does not actually go into the machine learning code or machine learning model itself. It goes into all the surrounding pieces that you need, the supporting infrastructure. Okay. Now, if you look at the supporting infrastructure, there are basic data management and compute management infrastructures. Let's get this. Now, one other thing, actually, this really bothers me a lot in this industry right now is going back to sort of the data and AI side that we talked about earlier. The industry at large right now has siloed sort of data technologies and AI technologies. This is just all the technologies I could name that's in the sort of the data space. They are very good for handling massive amount of data, doing whatever you want with processing data. And on the right, there's sort of the other type of technologies that are built for basically numeric analysis, machine learning, more massive. Right? And they're built by different people. They don't really talk with so the people that build them don't talk to each other. They don't understand each other. But if you think about this, depends on having a lot of that. Right? How could they actually be successful when the technology providers don't even understand each other? And it's not just the tech they build, it's also the people. I talked to a lot of our customers. For many of them, I asked them this question. When I see a data engineer, who's basically people that manage a lot of data infrastructure, I ask them, hey, do you know where your data scientists sit in the organization? Most of them, like, I don't know where they are. I only Slack them or talk to them on Microsoft Teams. And same thing with data scientists. They use different set of tools. They typically belong in different parts of the organization. For example, data engineers belong in IT. Data science sometimes belong in more of the line of business. Like, if you were to take a bank, for example, data engineer would be in the IT department. Data scientists would be in, say, the credit card department because they are the ones evaluating credit fraud. And as a result, when you sit in different teams and different organization boundaries, you don't talk to each other, and then things just fall through the cracks. Right? In order to actually make sort of AI or machine learning successful for this application to be built in the enterprises, and I'm talking about the ones east of Sacramento, I'm not talking about Silicon Valley companies, which are years ahead of the rest of the world. They need to fix this problem. Okay. The data technology providers need to understand the use cases and break down the boundary. The same is the sort of organizational cost. Right. So wrap up my talk. I think in short, I don't think there should be, the world right now has sort of a, hey, we're an AI company, we're more of a big data company. There shouldn't be a distinction really, right? Because the three trends are entirely intertwined. AI builds on data and builds on compute, which means for majority of the world, cloud computing is also the way to, you can to acquire compute because you don't have $1 billion to spend before you can run anything, right? So cloud is the essential to that. And we're hiring. If you're looking for someone, probably not this summer, but if you are interested, we're pretty much hiring any role. Feel free to email me, tweet me, talk to me, and you still have time for it.
Yes, I think we can do maybe we can do a 10-minute QA.
Sure.
And
Any questions? Ask anything, even the ones I didn't talk about. Yeah.
So you mentioned there are lots of components like when you do AI in terms of infrastructure. Like what is like Databricks so like in terms of components?
Yeah, we do pretty much all of them.
All of them.
We take an end-to-end view of this because one of the philosophy we have is we want to solve the problem end-to-end. We don't want to give you one piece of the pie and then you have to integrate with 50 other different things before you can even do anything. Right? We still integrate, but we want to make sure this can be a one-stop shop that makes it easier for so data scientists, data engineers to be building the applications. Yeah, so pretty much anything here.
So it means the customer, the only thing they need to do is like to input their data in their like those solutions, and then they can have their output like perhaps it's a chain model or some sort of like analytics.
Yeah, it's the reality is a little bit more complicated, but the most of our we are not a we are a platform, which means we provide APIs for our customers to leverage, and they do additional development on top of our APIs. Right? We are not a end-to-end is wrong. We're not sort of the vertical application. Like for example, we don't directly have something for you to make movie recommendations or music recommendations. You have to have your data in, and then you think about, so as a data scientist, what type of models would you like to train against this data set? Maybe you try like 100 different things. And then we provide the infrastructure for you to do that. We provide a way for you, for example, to track the experiments. We make it faster to actually train all of this. And then once you build a model and you figure out now how do I put it in production, right? We provide sort of a different framework for you to take that model directly and run it. I don't know how technical you are, but I said in Docker, and you can deploy it to Kubernetes clusters, so anywhere you want. We're not directly providing, hey, here's some model that's already built, and go use it.
What is your opinion on object storage replacing traditional Hdfs or blob storage?
Oh man, I wrote a blog post 2 years ago saying Hdfs is dead in the cloud. Object stores are so much cheaper. And I think that's one of the big problems with Hadoop. Sorry, it's not very technical, but the big problem with Cloudera and Hortonworks, basically they build their entire stack on top of Hadoop. And then two components are Hadoop file system and MapReduce. MapReduce got replaced by Spark entirely. Nobody uses it anymore. The file system in the cloud doesn't matter because it's too expensive, too difficult to operate. Object stores are way cheaper and way more reliable. So basically nothing is left here.
For a platform like as complex as like Databricks, for example, what did the MVP look like for you guys initially, and like what did you guys like initially target for like initial customer base?
Yeah, so this is a very good question. Our MVP, we technically didn't have like a MVP moment, but we did a very iterative approach of just rolling it out. Our first version of our software was very simple. Spark's great for interactive analysis, and let's build sort of some of the audience might understand, some don't. Let's build sort of a web-based notebook interface, and let's seamlessly integrate with Spark, and let's give it to customers and see how they like it. And then we soon realized data analysis is fundamentally a very collaborative business. Because it typically involves people from different teams, and even with the same team, a lot of different data scientists. So we wanted to create real-time collaboration. So on top of that, we added real-time collaborative editing. Think about Google Docs for like code, right? And code and data, so there's visualization of the data and all that. And then, so we added that, and that actually became pretty big. A lot of the companies that we talked to, after they used it, like, yeah, this like makes my data scientists 10x more productive. And data scientists were very expensive and very difficult to find. So for a lot of the companies, you can make them more productive. It's a pretty big value add. And then later on, we started going down, hey, to solve this problem, we need not just data scientists, but also data engineers. Because the data scientists typically work on data that's created by the data engineers. Like, these are the people that build pipelines. They get data from different places, clean them, and actually dump it somewhere. Right? So then a lot of the data scientists that in our customer base actually came to us and said, hey, really, right now you solve my sort of current problem, but I want to be able to get more data. And in order to do that, I need you to convince the data engineers in my company to use Databricks so we could actually solve this problem end to end. Then we started building a lot of the tools that's more focused for data engineers, like more API-based, like rather than UI now, more API-based stuff, because this actually writes scripts, and also focus a lot on, like, for example, reliability. Like, when you do something interactively, it fails, you do it again. When you have something that runs in production, you can't fail. So a lot of like reliability work, so sort of the journey. And then over time, so it became sort of a very customer-driven type of development on seeing, because given a large enough customer base, you can see a lot of the problems that are common across different customers and the challenges, and then you could actually come up with solutions to address them.
Hey. What was your process for realizing the need for Databricks?
Before starting the company or after starting?
Before.
Before. The question was, what's the process for realizing there's a need for the company, Databricks? It kind of went back to what I talked about early on, which is when we were doing sort of this open source project, we talked to a lot of Silicon Valley companies, worked with them, and we realized everybody was building the same thing internally. And usually they don't do a good job because that's not their focus. They have like a data team of a few people, and we have systems that break all the time. It's kind of clunky. And if Silicon Valley companies are this, right? All the companies east of Sacramento would have a really hard time because they can't even hire the Silicon Valley caliber engineers. So that's kind of what led to us to start this thing. But initially, it wasn't like there wasn't a very specific target we had in mind in terms of what exact product we build. It's more like in this general domain space, the tools are really outdated, very difficult to use. Let's make it better.
In general, are you like more of a fan of hybrid cloud or public cloud, or like what do you think is the relationship between the three?
Yeah, I am. So I definitely think cloud computing is the future. I think it would just be like utility or electricity. Very few organizations in the world have their own power plant, right? We certainly don't have one at home. I think the same thing will happen to compute, through cloud computing. Now, the transition could take years. Actually, it's an interesting one here. So when Databricks was started, we wanted to do cloud computing. And we're still a cloud company. Like basically, we only offer Databricks in the cloud. If you have your own data center, we can't help you. Like, we don't have a product here. We only have a product if you use Amazon Web Services or Microsoft Azure. And that was extremely controversial, especially in 2013. All the VCs we talked to asked us, "You sure? Are you sure?" Even the ones they invested in, they're like, "Yeah, I'm investing in the team and the people. I'm sure you will go on-prem. You go to the private data center. This cloud thing is too nascent. There's no money in it." And then in 2015, we still hear that 2016, actually when we talked to customers early on, they also said the same thing. They're like, "We're never going to go to the cloud. It's all my data is too sensitive to put in the cloud. I'm not going to dump it in Amazon or your cloud." And then in 2016, the conversation started to become, okay, we'll probably go to the cloud in the future. So let's talk again in the future. In 2017, it became, okay, we're thinking about going to the cloud now. How do you think I should do it? And last year, it sort of became, I already have a bunch of cloud projects, and they're not quite working yet. Help me. So we've seen sort of the whole world transitioning from very anti-cloud to now embracing the cloud in pretty much every organization we've talked to. And we believe the cloud is actually much better for startups, like not just as users, but also for vendors. And the reason is cloud is easier. It gives you a better delivery model. Like for example, in traditional enterprise software, if you have to install something in a customer's data center, you have to send people there to actually install it. And you don't have control of the kind of hardware they run. It's very difficult to do upgrades because you send customer DVD, for example, they upgrade it like 3 months later or 6 months later, sometimes 10 years later. Right now you have to maintain all different software versions. Whereas in the cloud, one version, you control the entire environment. You decide what hardware you want to run on. You offer as a service. And that's a much better sort of model that leads to higher engineering velocity and also leads to faster feedback cycle. Because as soon as you click, you click the button to push the new software artifact out, it's deployed everywhere. And customers can try it, and they can actually give you feedback very quickly, which actually improves the area of speed. And that's why we sort of affirm the view of the cloud. Now, I do think companies don't shift everything overnight, so there will be a lot of hybrid cloud solutions in the next few years. We ourselves want to focus only on the cloud because I think the best way of building a business is to focus on the fast-growing niche and be the best at it before everybody else gets it. It's not necessarily at the largest pie right now.
Right, last question.
This is a simple one, I promise. How big is your company right now?
We're about like 700, probably a little bit north of 700 people. But it changes every day.
All in the Bay Area?
No, it's very global. We have about maybe 350 in the Bay Area, and then the rest are sort of spread out across the world. Because a non-trivial part of our workforce is enterprise sales, and also like the technical sales. And those people need to be very close to customers.
All right, let's give a round of applause.
Thank you.
So, yeah, thanks so much for the amazing keynote and as well as the balance between the technical and the business side of the talk. So, for those of you who doesn't know, Reynold is a frequent speaker at the Spark Summit. So usually during his keynote, we just dive right into the technical stuff, just the dark side of the force. So, next up we have the CEO of Himalaya Media. So for those of you who have never been to China, you might not be familiar with the brand, but this is actually one of the most popular podcast platform back in China. And if I get this correctly, I think you raised 100 million from General Atlantic, SIG, and Himalaya China. So Himalaya, they're focusing on building a creator-centered podcast community and the network. So this is more of the platform side of the technology. Yu Wang, and let's give him a round of applause.
Thank you guys. By the way, these are the Chinese character of Himalaya. Himalaya, that's the tallest mountain in the world, and in the Tibet area. So I had the same challenge when I'm trying to make this talk work. I didn't know who the audience would be and what do you want to get out of this talk. So may I ask 2 questions? How many of you want to get some inspiration for your own future potential business from this talk? Okay. How many of you want to learn something about AI or buzzword? Fewer people? Okay, all right. I'm gonna focus a little bit more on the entrepreneurship and the inspirational thing. Well, first of all, let me verify your point. Yeah, everything we did at Himalaya is built on top of cloud, and it's wonderful. However, let me give you a wrong sense of security. Sometimes you think it's very reliable, and I did, and it was messed up. Because although it's 100 times more reliable than the things you build on your own, but once it stops working, you become panic and everything just becomes nightmare. Anyway, so out of this talk, I think what you can learn is the current situation or status of, in general, the global podcast industry, and what's missing in this whole voice-enabled world or audio business. So a little bit background of this company. So the company started in late 2012. So how many of you listen to podcasts, by the way? Okay, all right. So how about what's your most favorite podcast?
I would say Joe Rogan's podcast.
Joe Rogan?
Yeah.
You want some comedy shows? Yeah. Okay, all right. How about you? Sir?
Yeah, I didn't feel much of them. Like I can't really say anyone, but I even listen to one about the 96 yeah, I think that one was actually created here in Silicon Valley about like the intensity of working in like Chinese internet company.
Oh, the 96 thing?
Yeah, I think the podcast that was the 96.
Okay, all right, cool. So I think it's a good sign because back then, like 4 years ago, when I did the same research, very few teenagers or younger people listen to podcasts. Majority of the audiences listen to music. But over time, people start to realize you can make better use of your time. So you want something more informational rather than just pure entertainment. So podcast becomes more and more popular. And the fact is, podcast, the whole thing started as a very old format of content distribution, way of distributing audio. Like people would record and burn a CD of their audio and sell it to other people. That's the early days of podcasts. But the proliferation of iPhone and other smart devices make it easier to consume audios on the go. And the whole podcast industry just rise with the rise of smart speakers or the smartphones. However, podcasts never have a major adoption till last year. Guess what happened? Because in the last year alone, the whole podcast industry made about $400 million. That's nothing compared to the radio industry here, which is $18 billion a year, but it's still something because before that it was like almost zero. So when that money comes in, the whole ecosystem starts to flow, then more and more people look into this area, then all things start to happen. So this is the trajectory of the podcast industry in China, which looks very different from the United States. Well, in the States, the podcast started around the 2006 or 2007 when the first iPhone came out. In China, it started much, much later than that date. It started around the 2012. However, the growth rate of podcasts is a lot more crazier than the ones in the States. First of all, because there are more people in China, and the second, Himalaya made it a truly ecosystem other than just an app. So Himalaya started to convert a lot of things that was not in audio to the audio format. Then people start to realize that, yeah, I need it. When I'm driving to home, when I before my bedtime, I can listen to some stuff. And over just a little bit, maybe more than a year later, then Himalaya started to acquire 50 million users easily without even heavy promotion. And how they did it? They just acquired some top tier content, that the content you must listen to in China. So here, what are the content you must listen to or must watch? Think about that, and Himalaya converted to the audio version of that people would enjoy it before they're, when they're doing things. And it grows and grows. So the tipping point, well, as a platform grows, like a consumer product, something you need to think about is what would be the business model, right? Eventually, it's a business. You need to make money. So what would be the business model for podcasts? At the beginning, it's the same for every single other consumer product, which is selling ads, sure. But selling ads has a lot of difficulties. You need to have a strong sales team. and you need the advertisers understand the space and know the value of those advertisements, which was a little bit too early back then. And the real tipping point for the business is when Himalaya introduced premium content. The content people need to pay. That happened around the year of 2016. So after that, Himalaya and together with other content companies basically create a momentum of paid content. So before that, Chinese doesn't know that in order to get good content, you need to pay. But with this, with the effort of Himalaya and other companies, and also with the ease of paying by WeChat and Alipay, then paying for content becomes a very common thing in China. And it's more common than even here. Here, you guys listen to podcasts. You know you don't have to pay for podcasts, even the best ones, right? So after doing that, Himalaya just got a huge splash in the market. And they start to do a lot of things, like Knowledge Festival, those cool stuff. Because Knowledge Festival in China is like a TED conference here. So some numbers just to impress you guys. Okay, all right. So we have 500 million users. Well, actually it's the downloads. 5 million podcasters, which is a big deal because other than China, the rest of the world combined has about 600K podcasters, legit ones. But in China alone, we have 5 million people keep contributing the content. In terms of market share, among all the audio consumptions, Himalaya owns 73%, and the number keeps growing. And this is the craziest number. So for every single active user, they spend more than 2 hours on the platform on a single day. Can you imagine that? I couldn't believe that. I still couldn't believe that. But that's what it is. So Himalaya is not just an app. To the user, it looks like an app. It's just like Apple Podcasts or whatever podcast app you use. But in the back scene, there are a lot more going on here. So to make the whole audio ecosystem work, we were involved into content production. We even have the Podcaster University to teach people how to make better content. And we have the capability of distributing content almost anywhere. In your cars, in the traditional radio station, in the app, in smart speakers, even in a smart fridge. And the most important thing is for the top tier creators, we can generate real profit, not just for the company, but for themselves as well. So just give you guys some sense about what are actually the popular content over there. Just like the podcast here, what are the most popular categories? Comedies, true crime, news, politics, right? The same thing in China. We have a huge library of more than several hundred million pieces of audio and across all sorts of categories. So people's need about content are basically the same across different cultures. That's something we realize over time. So to give you a sense of the paid program that I've been talking about. So these are all celebrities in China, and Himalaya created a phenomenon that the majority of celebrities wants to make something for their followers in the audio format. They would collaborate with Himalaya to distribute that content. And the best seller among all these is the one on the left, which is a course to teach you how to communicate better. So I'll often teach you how to communicate to the difficult problem. I say, if you want a salary raise, how will you talk to your boss? If you get an F and you want to crack that thing, how will you talk to your instructor? So all those things, you may find this awkward if you want to do it yourself, but the course will teach you how to do that. And that's perfect for the audio format because what you need is just to learn or listen to those tips, and you can practice over time. The second one actually is about the same thing. It's about how to get a better EQ. And the sales they can generate is crazy. It's like the first one, they sell over 5 million copies in day one. So each copy worth about $30, $30 US. So you can see one single creator, well it's not one, but a bunch of single creators create this one course. I mean, a program can generate on the platform So not only the celebrities can do those sales or do those courses on the platform. Actually, Himalaya, with all the sorts of universities and the resources to develop the content, we can easily turn a grassroots. Grassroots here means nobody, right? So someone who's nobody into KOL, as the key opinion leader. So there were several examples of that. So the first guy become famous by narrating horror books. So he was like a regular college student like you guys, and he was nobody, and he started to narrate. He has a reasonable voice, but later on, when his books, the books he narrated get popular, more authors go to him say, "Could you narrate the book for me, and I'm gonna pay you." And this guy earns about 1 million RMB a month, which is 200K a month, US dollars, easily, without doing too much of work. Just reading. And same with the second and third. So, and live streaming. Okay, all right. You guys heard of Live.me or other live streaming apps? No, Twitch. How about Twitch? Right. So Twitch is live streaming for gamers, right? And this is live streaming for audio, which may sound boring, right? However, when we implement this, so many people go crazy with it. Before you go to sleep, if you cannot go to sleep easily, you may want to listen to some voice. Okay, all right. So maybe someone sings to you, maybe someone teach you how to go to sleep better, who knows? But these people are generating real money on the platform, even better than the people on Twitch sometimes. So in terms of the demographic of those 500 million users, they're young, they have higher income than average, they live in metropolitans. So which is great because the people on the platform are able to afford to pay for content, right? And beyond that, we can distribute the content in smart home furnitures or appliances, and a lot of those apps, just like Pandora or Spotify, is pre-installed into the car system. And also smart speakers and headphones. Turns out we have our own smart speakers, and just like Amazon Alexa and Google Home, it's the same thing. However, the only difference is we have the content. So by purchasing Echo or Amazon Alexa, you need to install skills, right? You need to say, okay, I want to listen to music, I want to listen to this and that. But with this, it can easily connect you to a huge content pool that you can just ask for it. So before, a lot of content, audio content, was produced by the radio stations. That's where the audio comes from, right? So now, since Himalaya becomes so dominant in China, so the game flipped. So now radio station go to Himalaya and ask for content to distribute, to help distribute. So, okay, all right, enough about the Himalaya. Okay, all right, so what about the Himalaya? So now a little bit background of myself. I was born in a small city in the northeast of China, which is very close to Russia, very cold city. They have ice sculpture every year, okay, all right. Then I had my college in Zhejiang University. Then I had my PhD at Emory University. After that, I started a company called Auto Radio, which is doing the similar business podcast thing, and was acquired by Himalaya a year ago. Now I'm the head of this Himalaya division, which is well funded by Himalaya itself and the 2 other venture capitalists. So because of my PhD, a lot of academia papers. So the first paragraph you need to do is to motivate why I do this work. And the best motivation you can have is to tie your research to a real world application. Otherwise, who would you care, right? So when I do this thing, the audio thing, I start to realize there is an empty spot in the academia world that was not done right in the research by the researchers. There's so much research about computer vision or speech recognition, or even natural language processing. But there's almost zero research to really try to understand the audio, especially spoken word audio. So that's what my background is, but the first step I need to make the research work is to build a product that everybody would want to use. Then my research can really have an impact. So some background about podcast industry in the United States. So number of podcasters, like I told you guys, is about 700,000 shows, but the really good ones are only about 30K-ish. Active monthly users, including you guys, are about 60 million users, which is still growing. But it's about 1/5 of the U.S. population, and a little bit about 10% in Australia. And revenue, like I said, in 2018 is about $400 million US. And all this, almost every single penny out of this $400 million come from ad sales, meaning that all the money is generated by doing ads in the audio rather than selling the content directly to the consumers. Okay, so why audio? That's a bigger question. So why people are listening to podcasts, right? Why we don't just watch YouTube? Why not reading news articles? So there are 3 points. Over time, people start to realize, okay, all right, audio is not strong in every single aspect, but there's something audio is better than video or text. The first thing people always mention, it's almost a cliche, is intimacy. Because when you wear a headphone, it's in your ear. So that type of intimacy or that close of relationship between you and the narrator or the creator makes something different. So the second is audio works better in certain contexts. Think about it when you're driving. Can you watch a video? Probably not, right? It's almost illegal. Before you go to bed, do you want to still watch something? Maybe, maybe not. I mean, that's the 2 peak hours of the audio usage according to our data. So, and when we talk about housewives, when they do work, when their hands are tied, would they watch a video or they would rather listen to something? Right? So, and the most important thing to me actually is the third one. You guys are watching Game of Thrones? The last season? You know how much it costs to produce every single episode of the last season? About $20 million. Every single episode. How many episodes we're talking about? 6 this time. So it's a bit longer than usual. But still, it's extremely expensive to produce those content. Well, Game of Thrones is okay because people know it's going to be a good show. How about shows are not so good, or you don't know whether it's going to be good or not? Are you willing to pay for such a premium money to produce the show? Maybe not. So, in return, I was talking to an executive working at Audible. I said, okay, if you put the best of yourself to do the top-notch quality of the audio program, how much we're talking about per episode? He said, okay, all right, that's gonna be about 10K. You guys can see the difference. Both of these are really the top tier quality of the shows. Okay, 10K versus 20 million. Okay, all right. So there is a trend in Hollywood now that people don't start to making new shows by just by shooting, but rather than they start to make a podcast to test whether this idea would work or not. So it becomes, because it's cheaper to make, first of all, and also it's easier to make. Think about yourself. As long as you have a reasonable voice, you know how to speak, you can start to make some podcasts. The fact is, 5 million people in China are doing that. So the combination of these two should result in a very vibrant community in the States that many of us are producing content, as long as we know what we should be talking about. But it's not the case. Why is that? Because you are earning almost nothing by doing so here. You are not incentivized by any real profit. And it's really hard to get listeners, drive listeners to your show. There are 2 pain points. Those are the 2 pain points I'm going to talk about. So The first one is content discovery. Okay, suppose you did a show. All right, who's gonna listen to a show? Where your show is gonna be on? Okay, on Apple Podcasts. And who will find your show? In what circumstances they will see, okay, all right, you did a great show, no matter how good it is. So that's our first pain point. Second pain point is monetization. Okay, suppose you have, say, $10,000 per episode, which is great. It's a big number. Can you make any money out of that? Almost not. The minimum threshold you can make any meaningful advertisement dollars out of your show is about $20K downloads per episode, which is extremely hard to achieve. And for the ones who already achieved that status, not every single of them has a great quality. They know some marketing tricks. So, okay, all right, what Himalaya did to solve these two issues. The first one is, well, we need to help the great content to get discovered, right? So how about hiring a bunch of experts in the content, just listen to each single new shows and try to curate some recommendations for the regular user. Sure, it can work. Apple Podcasts work in that way. But how many new shows the expert, how many people can hire? How many people can really, pick up the best ones? That's really a question mark there. So how about the next approach, playlist? We enable that curation function for every single user, not just the expert we hire, but every single user. Suppose, okay, I'm not a producer, I'm not a narrator, I'm not a creator, but I know a lot about AI. Can I create a playlist for AI? Yes, I can. In fact, I did. And I'm helping the community to discover better content by popping up some content people didn't notice. Okay, all right. But there is a limitation to all this human effort. Eventually, we want some good recommendation algorithms. So the promise is we want to let the machine to really understand the audio data, the text, and the feeling that audio creates. And also, can we leverage some of the data curated or created by those human beings to help with the recommendation algorithms? That was two main topics we were discussing. This is one of the approaches we tried, and they worked really well. And in fact, this is an academia paper I co-authored with some of the colleagues at the Cornell University, because I think their department head is a big fan of podcasts, and they want to do some research about podcasts, and said, great, okay, all right, we can collaborate. So this is gonna be, this is really about AI. Think about this. Suppose we want to understand audio. We know how to produce audio, right? But the machine doesn't. If you want the machine to really understand the audio, the machine should be able to produce similar type of audio over time, right? So in this thing, this little green bar means the audio thing, right? The waves. And we convert it into the frequency domain, and it looks like that. It's just a visualization of audio, okay? So if you give any algorithm, any generating algorithm to the machine, it will generate something like that. But turns out the machine randomly generated audio doesn't look like that at all. It's either pure black or pretty random or pure red, because machine doesn't know what the real audio should sound like. And then, okay, all right, that's not too bad. We can train a discriminator, meaning that, okay, all right, there are two components in this whole algorithm. One is the generator, try to generate something. And discriminator is trying to tell, okay, which one is generated by the machine? Which one is the real audio? It's almost like Turing test. Can you tell which is the real audio or which is the fake audio? Okay, all right. These two compete against each other. So after discriminator say, okay, it's so easy, you should do better. And generator learns, okay, all right, which one's so easy, and I can tweak it a little bit to make it a little bit harder for you to distinguish. And over time, the generator learns more and more, and discriminator finds it harder and harder to discriminate, but he can always find a way to discriminate. Then over time, both of them becomes really, really strong to the point that a generator can really generate some legit audio that a machine at least cannot tell whether it's real or fake. In that way, we are capturing some fundamental characteristics of those human spoken word audio. And by doing so, we're not only learn how to generate audio, that's trivial. I mean, that's not very useful. We can backtrack of the audio, the foundation of the fundamental characteristic of that audio to facilitate some classification work. For example, we can classify what are the calming sound versus energetic sound. And to do better recommendation tasks depends on the context of the users. So all that said, this is just one example of what machine learning can help in this particular application. So in terms of monetization, we're trying to adopt what's already very successful in China, which is the self-publishing. So every single creator can self-publish their own content, and they can earn all sorts of revenues with the tool the platform provided. So if you want to record a piece of audio for this, for example, this course can literally become a podcast. Then for the people who didn't choose to come here to listen to it, they can pay, $1 to listen to an episode of this. I don't know. So, okay, all right. The last topic I'm going to talk about has a lot of opportunities for your business ideas, which is the voice. We talk about so much about audio. So what about the voice? Because when you're searching or listening to audio, probably your hands are tied, so you cannot really tap in, or it's tedious to tap in and search. So how about using voice? In fact, Alexa and Google Home are encouraging that type of behavior, right? So in 2018, already 1/5 of the search happens in voice. And people predict in 2020, it will be 50%, which is crazy to me. And how people use Alexa now is the first one, well, the alarm clock is a real technology. People use Alexa mainly for setting the timer. And the second usage is to listen to songs. And the third one is to listen to news. So you can see that without very good understanding of what people need, the application is really limited. I mean, you can easily achieve these things without even Alexa, right? The reason is Alexa doesn't understand the query really, really well. It doesn't understand your information need. So to complete the whole loop, how the voice search system would work. First of all, you need to take the voice in and analyze it to convert it to text. Why is that? Because there's tremendous amount of research about understanding the text, the natural language processing part. There are tons of papers about it. Okay, after that, you would say, okay, all right, give me a sentence. Say, what's the top song of the year 2018? It's a very natural question to a human being, but it's a very hard question for the machine to understand and find the right answer. So you somehow need to convert that question or information need to the language that machine can understand. What the language machine can understand? SQL queries, if you know what it is. Okay. All right. So then you have some answers. Okay. If the answer is simply a web page or a number, it's easy, right? Just give it to the user. But if it's an idea, how would you translate the idea into some synthetic text and send it to user? That's probably the most difficult question in the history of computer science, because that's basically the ultimate artificial intelligence. You have an idea and you know how to express it. And the fourth one is actually pretty easy, how to convert the text to the audio or to the voice and send it back to user. So every single part here now are more than $1 billion business. So I would say the part 1 and 4 are almost the solved problem in general settings. So I don't encourage you guys to try to start another company, try to solve ASR or TTS in general application. That's not going to work. However, there's still opportunity there. If you focus on a very special vertical, then you can do better job than the average ASR system or TTS system. That's doable. But 2 and 3 are the holy grail of artificial intelligence. If any of you can make a little breakthrough, we're talking about $1 billion valuation of your company. So you guys know Google made a podcast app, right? If you guys use Android phones. Google make a podcast app. It's a terrible app compared to what Himalaya did. Well, the reason they make a podcast app is not about they want to enter the podcast industry. At least that's not their overall goal. Their overall goal is trying to index the voice and make voice or the audio searchable, because Google is ultimately a search engine, right? So to really tackle the whole process, you need to index audio content, and Google did so. And then you need to really understand what kind of content you are really looking for. And then you serve the audio. That's the whole loop. And with the smart speaker we developed, we think, well, we definitely did the first one because we are the content itself. And the second one is challenging. We're working on it. We achieved something so far. And the third one is just through our distribution. So far, the smart speaker we produced is the most engaged smart speaker in the market because we have a lot of content. So after all, I think I would just want to summarize the talk today. I gave you guys a brief introduction about China podcast industry and the global podcast industry. And the fact is, the global podcast industry is almost the same as the English podcast industry because there's no other languages still in the early days of doing podcasts. And a lot of big companies from Europe are talking to the podcast companies like us and Spotify, trying to see if it's the right time for them to create a podcast. Then the third one is the technology around audio and voice, where the opportunities lies in if you want to start your own business. It's a very general, and I'd like to take any questions if you have any.
My question is, as someone who has a successful model in China and kind of like bringing this product to the States, what's your strategy against, say, for example, Spotify entering the industry?
How many of you use Spotify to listen to podcasts? Okay. You guys know how Spotify approached this? They recently spent, I think, $500 million to acquire a bunch of production companies, podcast production companies. And in return, well, they're not only promoting their in-app podcast, but also they are encouraging the producers which they acquire to promote their thing. However, the result is very interesting. I talked to a guy from R19, which is the largest podcast hosting company. He said, yes, Spotify is growing quickly, but they are not actually stealing the user from other apps. They are converting the music listeners to become podcast listeners. So yes, they are doing that, but they are basically leveraging their own users to do so. Spotify did this because they are paying billions of dollars to the music label company every year. So to lower the usage of the music, then they can save a bunch of money. And podcast is free, so they are doing that mainly to save some money. I think the question is really not about whether a China company or Chinese company can really tackle the space. It's more about, okay, suppose you have enough funding, what would you do to really enter the space? Okay, Apple is dominating the space. Spotify is converting their users. I mean, we're talking about 300 million users, and there are other little ones. So the strategy of Himalaya, like I think Bob told you guys, is really to help from the creator side. So how we can enable more people to produce content, how we can build the tools for any creators to not only produce great content, and how to help their show grow and eventually get revenue. That's the three main pain points we see from the creator side. And if we can make that happen, I think, well, the market will tell.
Just a quick question. So like, I know TikTok's emerging right now as like a content creator, like great place to be. So like, as a creator, why would you go to a place like a podcast place rather than like do TikTok where like they have a huge audience where you can easily become someone famous really, really quickly?
Good question. You know the history of TikTok? It was Musical.ly.
Musical.ly, yeah.
Right. So Musical.ly will have this peak time maybe 3 or 5 years ago. and then they were acquired by ByteDance, and ByteDance converted pivot the business to TikTok. TikTok is doing great, but I'm talking to so many influencers now, and one thing all influencers share is they don't want to put the eggs in one bucket. They want to be everywhere. They are on Instagram, they're on YouTube, they're online, they're on TikTok. And what about audio? Audio is missing in this equation, right? So when we talk to them, they're so excited about the opportunity they can try something new. So, but the question is, okay, what would be the benefit of doing this? Would I get additional revenue, or would I get additional followers? So again, we are back to the pain points of the creators. How would you grow your show? How would you get it monetized? So if we get those two things right, and it's a new format of content for you to try, it's very easy to actually work with them.
Can I know, like, so what of the Himalaya, like the company here, still that's different from Himalaya back in China?
Right.
Because I feel like all the things you mentioned, like help them get discovered and monetize. I think that probably have been followed like back in China already.
Exactly.
Can they just you apply the same thing here? What's the difference between China and the global market that need the separate company?
Right. Over time, I realized the basic human needs are essentially the same. Doesn't matter which culture you're from, doesn't matter where you're from. You need to get noticed. You need to get money to sustain your business. That's the same thing across, no matter where it is. But how to approach this, how to solve this problem, depends on which context you're talking about. In China, it was easy because there was no competition, and Himalaya is the dominant platform, so it's easy to do so. But here, it's a little bit different. Okay, all right, ads is doing great, $400 million per year, but okay, how we can introduce something new that for the market to adopt, right? We are trying to do something new to generate new revenue source for the creators. How would you educate them? That requires a completely new approach. But yes, we're solving the same problem for different people. But how to do it is a little bit different.
So speaking of the competition, would you consider Zhihu as your competitor because they also offer those paying content?
Right. Well, the truth is, I think they are a little bit late to the game. Right. They are offering a lot. They are doing that because they see us being very successful in that domain. I think they still have their chance, but relatively smaller, restricted to their own users. And as far as I know, they're not doing quite well in other areas. They kind of get squeezed by so many different platforms. There was a story that I heard like 1 year ago. Total basically take over 100 of their top creators overnight. So
For their own, like,
right. So the platform, what's the most important element on any content platform? The content. Who produced the content? Creators. Who get creators wins the game. So that's very simple.
Yeah. So I'm a creator myself, and what I've seen is that I guess produce podcasts, but I do it in video form because the revenue is a lot higher. And I've seen I've been noticing a shift from people who do podcasts, and now they're filming it and uploading it on YouTube or whatever. I've seen a big shift from popular podcasts to include video just to create another revenue model.
Right.
Do you and that's pretty much what I do as well, because it's I don't know, I guess easier.
Right.
And easier to make more money too. But do you see that as a shift that's going on, from going audio to just long form video?
I see the shift that happens in both ways. Top tier podcasters start to do videos because just like the theory I said, true influencers want to be everywhere. They want to do audio, they want to do video, they want to do Instagram, they want to do everything. TikTok. So why you don't? Well, you are sitting there and recording, why don't you just record the video at the same time and put it on YouTube? It at least won't hurt, right? So, and I also see a trend that top YouTubers doing podcasts. Because what I can tell you is, okay, YouTube may be a good revenue source for you. How much we're talking about, CPM wise? $10? 20 at most?
Yeah, like 20.
20, right? So the lowest CPM on podcasts, you know how much? CPM is cost per 1,000 impressions. So if 1,000 people listen or view his work, then he will get that much money. This is $25. Podcast listeners, well, you guys may know, are so loyal to the creators, and the sponsorship type of ads is working so well for both the creators and the listeners. So the CPM is crazy high for podcasts.
It's 25.
25 minimum.
What's like the range?
25 to 100.
Audio actually, earning rate of audio like YouTube video.
At the moment, yes, because YouTube is so saturated, and audio is still, developing. And at the moment, I think, well, just a matter of can you get legit, number of followers, and can you get a good sales team to sell the ads for you, right?
Yeah.
Right. So, but anyway, I think a good influencer or creator should do all sorts of things.
From like from an advertiser's perspective, like how is advertising on a podcast, say, more beneficial than like say a Facebook or like something like visual or video? Because it's like personally, like if I'm on like Spotify listening to a song and I get hit with an ad, like the likelihood of me like say swiping up or clicking on it is pretty low. That's just like personal thing, obviously.
Mm-hmm.
Like I'm just like you're more experienced in that than I am in that.
Exactly.
So I'm trying to figure that out too.
For the ads on Spotify, it's not real ads. I mean, the CPM is so low, it's more almost like a tool to convince you to convert to be premium users, right, for Spotify. The reason why the ads in podcasts work is, well, there's all sorts of format of ads on podcasts, but there's only one type can work. That's a sponsorship, like host rep. The creator need to be very authentic to sell the thing. So, for example, if the creator you like, Joe Rogan, say, okay, I think I found a really cool toothbrush. Quick, or it's everywhere on the podcast, in the podcast world. You would definitely give it a shot. Most likely, at least check out the website, because you listen to him. He's almost your friend. He's in your ear every single day. When he says something, you pay more attention to that. Other than say, okay, between sounds, some random dude say, okay, there is a toothbrush. Who cares, right? So that's why the CPM can be so high.
But then, like from like an advertiser's perspective, how do you even track that though? Because like you're listening to this constantly,
Right.
but then you can't track the actual like click-through rate as like an individual
That's a good
going
question.
to your site.
That's not a solved problem, by the way.
Yeah.
If
Okay.
anyone can solve that, that itself is $1 billion business. Or for now, a lot of podcasts use Decode to track that.
Yeah.
So that's how it works. Did it work great? No, it may only work 50% of the time. But based on my colleagues in other companies, what they've been telling me, I can tell you this is a public company and they were trying all sorts of advertisement platforms, Facebook, podcasts, YouTube, all sorts. So podcasts achieve the best CPA so far. CPA means cost per acquisition.
Acquisition.
Yeah, so which is only a third of what they're paying on Facebook. So that's encouraging, but that doesn't work for every single product. You need to really find your product. But yeah, it's happening. The ads
Awesome.
is really
Thank you.
Going well. All right, thank you guys. Thank you.
So much for the talk.
All right.